Good morning everyone. Last time we have discussed speed and velocity. Today we will discuss acceleration and graphs related to motion. So, what is acceleration? Acceleration Acceleration is rate of change of velocity with time. See here. This is the definition of acceleration. The SI unit of acceleration is meter per second square. How? See, acceleration is denoted by A. Small a. Its SI unit is meter per second, that I will explain you later, and it is final velocity minus initial velocity divided by time. How? I said that acceleration is rate of change of velocity. Initially, suppose your car is moving with velocity 40 kilometer per hour. We always denote initial velocity with u. 40 kilometer per hour. And after 1 hour, its velocity becomes 70 kilometer per hour. Kilometer per hour. So, the change of velocity will be v minus u, final velocity minus initial velocity divided by time, because the definition of acceleration is rate of change of velocity with time. This quantity gives us acceleration, which is denoted by small a. Now, see here. This definition I have discussed, SI unit I have discussed, this I have discussed. Now see here, body travels in straight line and its velocity changes at uniform rate. Like in uniform motion, I have given you example of Virat Kohli makes 4 runs in every over. Similarly, if a car speed increases 20 km per hour speed every hour, then it will be called uniform motion. The increment in the velocity of car is same in every hour. Whereas in non-uniform acceleration, case is opposite. That is, velocity of body increases unequal amount in equal interval of time. Like same definition we have discussed in non-uniform motion, which is the same, that is, the distance covered by a body is unequal in equal interval of time. So this is the basic difference between uniform acceleration and non-uniform acceleration. Uniform acceleration, in which body travels in straight line and velocity changes at a uniform rate, whereas in non-uniform acceleration, velocity of body increases by unequal amount in equal interval of time. Example of non-uniform acceleration is same of non-uniform motion, like a moving car in a crowded place. Sometimes your car speed or velocity is more. Sometimes when there is a crowd, then you decrease your velocity. Now, see here, acceleration. So, if question comes, define acceleration, then you will write this. It is the rate of change of velocity of an object with respect to time. Mathematically, we write v minus u by t, where v is final velocity, a is acceleration, u is initial velocity, t is time. It is denoted by small a. Its unit is meter per second square. How? A is V minus U divided by T. Unit of velocity is meter per second divided by second. So this S will go up and will make minus 2. Base same power add. So power of S becomes minus 2. That's why the unit of acceleration is meter per second square. Now types of acceleration. Same uniform acceleration and non-uniform acceleration, which I have discussed initially with you. Differentiate uniform acceleration and non-uniform acceleration. Acceleration is said to be uniform if it increases or decreases by equal amount by equal rate with respect to equal interval of time. This is the definition of uniform acceleration, whereas non-uniform acceleration is when it increases or decreases by an unequal rate with respect to equal interval of time. Just opposite of uniform acceleration. Example is freely falling body. When you drop a ball from your hand, its velocity increases at a constant rate. That's why it is an example of uniform acceleration. This freely falling body we will discuss in next chapters. So here you only have to learn the example of it. Example of non-uniform acceleration. Same, a moving car in a crowded place. Now, I will discuss with you numericals related to acceleration. This graphs I will discuss later. So first we will discuss assignment question, which are same of NCERT question in your book. So I'll discuss here. See here. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to other and back along the same straight path. Find the average speed and average velocity of Usha. Yes, this is the numerical related to average speed and average velocity. This was left, so I included this question in this assignment. See here, Usha, there is a swimming pool of length 180 meter. Okay. This is point A. This is point B. Usha swims from point A, goes to point B, and then comes back to point A. In this, she takes 1 minute. 1 minute means 60 seconds. We always convert minute and hour into seconds, except when it is mentioned in question that you have to calculate speed acceleration in kilometer per hour square or kilometer per hour, etc. Otherwise, the unit should be meter per second or meter per second square. Always remember this. So, we know that average speed is total distance covered divided by total time taken. Total distance will be 360. How? Because, 360 not, 180. Why? This length of AB is 90. Usha again swim from B to A. It means total distance will become 90 plus 90. So that's why the total distance is 180 in question. And total time is 60. So divide 180 by 60. Like you can see here, 180 by 60, which comes 3 meter per second square. 0, so 0 cancel, and 6 3s are 80. And unit will be meter per second. Average velocity will be 0 because in case of average velocity we take displacement upon total time taken. The displacement is 0. Why? Usha swims from point A to B, then again comes to initial point. When final point and initial point coincides, displacement will become 0. So the answer will be 0 per meter. The average speed of Usha is 3 meter per second and her average velocity is 0 meter per second. Now, this is the question of acceleration. Starting from a stationary position, Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. Then he applies brakes such that velocity of the bicycle comes down to 4 meter per second in next 5 seconds. Calculate the acceleration of bicycle in both cases. Imagine yourself that you are going to your friend's home. So initially your bicycle will be at rest. So in that case, we will take initial velocity u, which we always denote by u, 0 by it is mentioned in question from stationary position. And final velocity is 6 meter per second. Rahul pedals his bicycle to attain a velocity of 6 meter per second in 30 seconds. So we will become 6 meter per second. Time is 30. We know that acceleration is equal to v minus u by t. This you will learn later. So you can write it as this form or this form. It's your wish. Since I have not introduced this equation, so I would prefer you write this equation. So we have all quantities here. V we know 6 meter per second, U 0. Yes. V we know 6 meter per second, V we know 0 meter per second and T 30 seconds. So substitute the value of these. You will get 6 minus 0 divided by 30 divided, which comes 1 by 5. 1 by 5 is equal to 0.2 meter per second square. See here, the unit is meter per second square. As we know, unit of acceleration is meter per second square. Now, the second case. Then he applies brakes such that velocity of the bicycle comes down to 4 meter per second in next 5 seconds. Here, now Rahul continues to pedal his cycle. So his initial velocity in this case won't be 0. His initial velocity will be 6 meter per second by which cycle is riding. After applying brakes, we know that when we apply brake, our speed of bicycle starts to decrease. So in 5 seconds, its velocity becomes 4 meter per second. So in this case, the initial velocity is 6 meter per second, final 4 meter per second, time 5. So again, we will use that formula of acceleration. We will substitute all the values. In this case, acceleration will come minus 0.4 meter per second square. Minus sign suggests that you have applied brake to your vehicle. Whenever we apply brake, its acceleration decreases and acceleration value comes negative. So this negative acceleration is called retardation, which I will explain you in this note when the definition comes. Just remember, when acceleration is negative, we call it retardation. Okay class, so in first case the acceleration value comes 0.2 meter per second square. In next case, it comes minus 4 meter per second square. Now the second question, first question of page 103 is, when will you say a body is in uniform acceleration? Second case, non-uniform acceleration. We know, as I have discussed with you earlier in definition, a body is said to be in uniform acceleration when it moves along a straight line and velocity changes by equal magnitude in equal interval of time. This is a case of uniform acceleration. And second, when do we call a body is in non-uniform acceleration? When it moves along a straight line and its velocity changes by unequal magnitude in equal interval of time. Example, same moving car on a crowded street. Again, the numerical related to acceleration. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find acceleration of the bus. Now, bus speed initially was 80 because it has mentioned in statement bus decreases its speed. So, initial velocity would be more than final, and final velocity is 60 km per hour. So, first we will convert kilometer per hour into meter per second. How will we convert? We always convert. See here, 80 kilometer per hour. 1 kilometer is equal to 1000 meter. And 1 hour is equal to 60 into 60, which comes 36 seconds. Okay. Now, 80 kilometer, replace kilometer by 1000, and since r is in denominator, so we will write 3600 here. Divide, it comes like 1, 8, 10, 9. So it will come 50 by 9 meter per second, as you will see in the question. See here, they have not solved. I have solved it. So it comes like this. Okay. Or you can do again by yourself. If I do here, let me see what it comes. 80,000 divided by 36. So here they did 5, 1, 8, 49. Yes, it comes 200 by 9 meter per second. Similarly, you will do for final velocity. Try to do yourself. If you don't find answer, then contact me on phone. I'll tell you. Time is t. Put values in it. We put the values of v, u and t. Will get this minus 1.1 meter per second square. Minus shows it's a case of retardation where we are applying brakes to vehicle. Third, a train starting from a railway station and moving with uniform acceleration attains a velocity of 40 km per hour in 10 minutes. Find its acceleration. So, a train starting from a railway station means train would be at rest. You know that whenever you catch a train from a railway station, the train is at rest. So u will be 0 and final velocity will be 40 since it's mentioned here. Train attains a speed of 40 km per hour. So we will convert first V into meter per second. Again 40 into 1000 divided by 3600. Calculation, it comes 100 divided by 9. I won't solve it because then calculation will become tedious. T 10 minutes, I'll convert into second. 60 into 10 means 600 second. Using again this formula of acceleration, it gives 0 minus 100 divided by 9 divided by 600. So 100 divided by 9 into 600. This 600 will come in multiplication with 9. So do the calculation here. You will get minus 1 by 54. On calculation, it comes 0.0185. I forgot to write negative, so write minus 0.0185. So these are the questions, numericals related to acceleration. So please write minus 0.0185 meter per second square. Now I will discuss with you graphical representation of motion. That is how quantities varies with time. See here, first graph, distance time graph for uniform speed. That is, your car is moving with uniform speed. Means in 1 second or in 1 hour, you have covered 50 kilometer distance. So, and in second hour, you have covered 100. In third, 150. In fourth, 200. If you connect all these points, you will get a straight line. So this will be the graph for uniform speed. Whenever a question comes, draw a graph of distance time graph for uniform speed, then you will draw this. You can take any arbitrary values of distance and time. Teachers will see whether you have made straight line or not. This is a case of uniform motion or uniform speed. See here, in second case, the distance time graph for non-uniform speed. It is curved, like I have explained you an example of Virat Kohli, in which in first hour he makes 3 runs, in second 4, which becomes 7 total, in third 14 runs. So if you connect all the points, you will get a curved path, curved line. So this type of graph is for non-uniform speed or non-uniform motion. These graphs are very important. Question will be asked, draw distance time graph for uniform speed or uniform motion. Then you will draw this graph. And if question is asked, draw distance time graph for non-uniform speed or non-uniform motion, then you will draw this graph. So this is very important. Now, distance time graph for object at rest means I am sitting in my room, I am not changing my position. It means with time the distance will be same as it is. If my distance from my other room is 100, then it will remain 100 because I am not moving. So in case of body at rest, the distance time graph is parallel to time axis. This line is parallel to time axis. This is also important. So remember this. Next is velocity time graph. Velocity time graph means you will write velocity in y-axis and time in x-axis. Whenever any graph comes, then one quantity you write on y-axis, another on x-axis. So the first is velocity time graph of an object moving with constant speed. Here the graph is parallel to time axis. Why? Because it is mentioned that object is moving with constant velocity. Means in 1 hour, speed of object is 40 meter per second. In second hour, it is also 40 meter per second. Like you can see in graph, in 2 second, value of velocity is 40. In 4 second, it is 40. In 6, 40, 8, 10, all values will be 40. If you connect all these points, it will show a line parallel to time axis. So this is the case of velocity time graph with constant velocity. Same as we have seen in case of distance time graph when an object is at motion. Next is velocity time graph for uniform acceleration. Whenever uniform comes, just draw a straight line like that and write velocity time or whatever it is mentioned here. If it says distance time graph for uniform motion, then you will write distance here and time here and you will draw like it. Whenever uniform comes, draw a straight line. And when non-uniform comes, then draw a curved line. That's it. The quantities will be given. You will write according to that. That's it, class. Today I will discuss these graphs only. Remaining graph and definition I will discuss tomorrow. Thank you. If you find any difficulty, call me. Don't message me or don't WhatsApp call. Only phone calls I will attend. Thank you.